Okay. So hello, everybody. Welcome to what I am trying to make happen, which is sort of this like end of semester OpenStack meeting. And the reason I want to have this is really to allow people to kind of show off what they've been working on and talk about what like kind of stuff is going on the student side, on the research side, on the professor side, and then also on the administration side. And so for today's agenda, I've kind of thrown together just a few talks. There's a lot of me talking, and then I've sort of added some other talks in here as well. And so hopefully people could watch this back afterwards and then kind of find out where OpenStack is right now, and then also what are some cool new things that might be going on in the future for the SCS OpenStack. And so I do hope to run another one of these sometime in the future. I'd love to have more people come in who are using the OpenStack for different purposes and talking about what types of stuff that they do as well. But so the goal is really to show off what we're doing. So give like small talks about some of the stuff that's going on, but also really to sort of like galvanize each other to have reasons to get more hardware. Like if we find like really great ways to run more stuff on the OpenStack, then I think it's a really big reason that we should be able to push for more hardware for cool things. And so I personally find this quite exciting myself. And so just for a little bit of context, if you're coming here as a student, if you don't know very much about the SCS OpenStack, it's essentially it's like a cloud. It's a lot of servers that the School of Computer Science has running, and the School of Computer Science manages these servers and offers them to different courses and to different student projects and to different research projects. And so this is sort of like just a lot of computers from like the sense of a student. Like if you're a student, you're going to go on, you're going to make like a virtual machine, you're going to do some stuff with it. But then if you're doing research, there's going to be a lot more that you do as well. So a little bit of an intro for myself. So I'm an undergrad student here at Carleton. And I've been part of the Carleton Computer Science Society for several years. I've been working on quite a few different projects here. But I also, actually 1 second, let me just reload this because I added I love servers, very cool. I did want to also mention, so I'm a Rustation, I like programming Rust. Everybody who knows me knows I love talking about Rust, but the reason I bring this up is because I run another meeting for the core Rust teams to be able to talk to one another about important issues, not really issues, but like tech talks that are oriented towards the stakeholders. And that's sort of what I want to bring into this type of meeting, where it's not necessarily just about like a general public facing tech talk, but it's like what can we do internally, or like what are we doing internally with the OpenStack. So next I will kind of want to just dive into what I sort of see as like the state of students right now, and a lot of what I've heard from a lot of different angles, where like from first year students, they ask the questions very often: can I get an M1 Mac? Is it going to work for me? Then we also obviously have the very big case of accessibility online, so students being able to do their coursework well, not situated on campus, not being able to use school computers, and how does that look from the perspective of us, or rather the School of Computer Science serving the OpenStack, but then also from the perspective of students, what does it take to understand the concepts that go into like what a virtual machine is, what is the cloud, how do you manage it, and stuff like that. And so I also just want to mention quickly some of the usage in courses. And so I know there was several people who weren't able to attend just because it's a very busy time of year. But obviously the OpenStack is being used in a ton of courses. And something I find quite interesting is that there's a lot of first year students who are using virtual machines to be able to do their first year courses, because it's just easier for them on their system, or they just want to connect to something remote. But I think that's really awesome that first year students are able to do this. We of course, I've heard from a lot of students that they've been really breaking some kernels and everything in Comp 3000, so that's pretty cool. We have students cracking crypto on virtual machines, and lots of other courses are using it. So from the perspective of coursework, there's a massive amount of usage of the OpenStack. But I really want to explore for my point, I want to explore like what is it being used for, like with student projects. And so Over the past several years, I've run several different hackathons that have been oriented towards creating content for students in different courses at Carleton. And so one of the big ones that I ran several years ago was Hacking 2804. And our objective was that we wanted to find better ways to impart some of the course content onto students. And so creating a place that they can go and get resources to learn from more easily, a place that they can go and do quizzes. We explored visualizing some concepts in the course. And this project was sort of a seed for what was to come later. And so we have Matt here today, who's going to talk to us a little bit about some of the projects that have stemmed out from this. But then more recently, I ran another hackathon called Hacking 1000. And our objective was to just try and create a breadth of projects that could be useful to first-year students coming into university and into Carleton. And so I'm going to talk a little bit more about this in my sections coming up, in which I'm going to talk about like how we're running stuff with the infrastructure and running several different projects. But first of all, I want to pass it over to Andrew to talk a little bit about the state of OpenStack. And so from the perspective of the person running the OpenStack, running the hardware, setting everything up, kind of just hearing where it is right now and where it's going to go in the next few months. So I'll pass it over to you, Andrew.
Sounds good. So basically, I'm going to give an overview of sort of where OpenStack has come from in the School of Computer Science and where we're hoping to take it over the next year or two and into the future. Did you give me screen share privileges? Yes, it looks like it.
Yeah, let me just stop sharing mine. So we'll see if
I'll quickly
that works for you.
Share screen 2. Okay, so can everyone see that?
Yep, looks good.
Okay, so basically just give a very quick history. I'm Andrew Pullin, by the way. I'm the senior software designer, and one of my responsibilities is the SCS OpenStack. So I put together the original pilot project back in 2014, 2015, and then I've been running it through its paces ever since. So just looking at it, this is a picture of what things looked like back in 2015. So this was sort of our little pilot setup. You can, it was very simple. We just had a few very old compute nodes from a previous network with very, very little CPU or anything like that, but it was enough to get us started. We were doing a bit of experimenting with things, and for anyone who's used to OpenStack, you may notice there's one difference. And that's the fact that you could actually, back then, you were able to get to OpenStack from outside of the VPN, so outside of the Carleton network. And we sort of tried that out, and students did like it, that they didn't have to VPN in, but, and we had exposed a certain number of subnets, IPs on one subnet to OpenStack, so some of our people could also run things by bypassing the Carleton network entirely. So, but things obviously changed. So the next iteration, major iteration, came in 2018, and that's where we made the decision to sort of change and put everything behind Carleton's VPN, just for the additional protection that ITS provides through their firewalls and everything. And it adds a bit of an extra layer. We do have to put in some firewall requests for some public facing things, but it's not too onerous. They usually can get them done in a day or two. The other big thing, by 2018, after several courses had run, there was a fair amount of interest in OpenStack, and we actually had the first researchers who, over the previous couple of years, added their infrastructure to OpenStack instead of just buying standalone servers. And so that was the chorus group, and then the machine learning group. So sorry. And so they were our first research groups that were using it. They had their own hardware, but they were using all the same infrastructure, so the same controllers, storage, all that stuff. The other thing about this iteration of OpenStack was, compared to the previous one, you'll notice there was a networking container. And back then, the neutron networking went through a single node. So all the networking was fed through this single node, and we did have it trunked, but or bonded connections on it. But it did mean we had a single point of failure back then. With the new neutron networking, that made things a little, I guess, safer, if you will, because now all the compute nodes would connect directly to the what we call the provider network. So that's the network that you get your floating IP addresses on. So whenever you assign a floating IP address, you get on that provider network. So now, even if something happens to the controller, in theory, the controllers can die, the storage servers can die, but the actual instances running on the compute nodes, as long as they still have their network connection, you won't lose what you're working on. So you can't log into OpenStack and launch something new, but that was a big help. It added a bit more stability, especially when we had to do updates on our controller. So that's sort of, it's a picture of the way things are now. Mostly there has been a bit of modification to that, but that's essentially what things look like now. We just have a lot more compute now than we did back then. So back then when we started in the beginning of 2018, we got 9 new servers, and there were, obviously, as you can see from the stats, like instead of 4 CPUs per server, we had 40 to 56, and way more RAM and disk space. So that really allowed us to, for the first time, host a few of the really big 300 or 400 student courses. So, and then I guess moving on from there, this is sort of the plan for the next generation. So hopefully you can see all of it. It's not cut off. But for those who don't know, we are transitioning out of the SCS server room. So the School of Computer Science runs a server room in the Hertzberg building, but it's been giving us a lot of trouble with air conditioning and everything else in the last years, and we've pretty much maxed out the power capacity now. So we've come to a tentative agreement with ITS to move into their data centers. So they have the 2 big campus data centers. One's in Robertson Hall and one's in the library. And so we've been working with them, and this is sort of the structure we're going to be going with going forward. The big change from our perspective is we're going to have, for the first time, true high availability on everything and true multiple zones. We've only ever had one location, so if we lost the connections to that room, everything would go down. But now we're going to be able to host equipment in racks in both facilities. They'll basically the main Carlton switches that connect the two, they'll give us about an 80 gigabit backbone to be able to connect between our networks. Everything will be dual homed, so you'll be able to log in at the same IP and it'll send you to whichever one you're going to want. And the nice thing for our researchers and for specific courses, if you have things that do have HA considerations, like you need to make sure it doesn't go down, you could run, we could provide you with 2 zones to your OpenStack project. So you could launch your web server in one zone and then a backup web server in another zone, and then you wouldn't lose your connection even if one of the data centers went down for some reason. So, and obviously it comes with all the other great things about a top of the line data center. It's got brand new air conditioning, it's massive amounts of power, and it has its own generator backups. So a lot of the issues we've had with power reliability will all go away in the new facilities. So, and then just to support the high availability, we're also, before most of our controlling nodes were all running at the hardware level, but now it just made sense at this point to make the step to virtualize the actual control aspect of OpenStack. So we'll be running on probably LXD containers. We haven't decided 100% for sure, but we're leaning towards LXD to run containers for that. And as you can see, we have a lot of compute. This is more reflective of what we have right now. So we have 9 GPU servers now for a total of, well, what's 9 times 8? A lot of GPUs, and that's available for our courses. Our researchers also have a lot more compute. We have a lot of GPUs. The machine learning group, they have they have, I think, 24 GPUs now in total. So there's a lot more power here, and so we're able to support a lot more courses, and especially things like machine learning and AI. So those types of courses, they were able to test stuff with us before, but they couldn't really do any real long run high compute stuff. They would end up going elsewhere to do their serious runs on their work. But now more of it can actually happen on our own compute and our GPU servers. So, and I think that's about it. Oh yeah, and the other advantage of being here is that we'll fully be able to take advantage of the 2 incoming, and I guess soon 3 incoming connections to Carleton. One's on Rogers, one's on TELUS, and I think a second one's going to be coming in from Rogers. So that will also provide a bit more redundancy for OpenStack. So. Okay, so I think that's it. I'll stop this share. Was there anything else specifically you wanted me to talk about, Forrest? Oh, can't hear you right now, Forrest.
Hello?
There we go.
Oh, you can hear me now? Okay, perfect. I guess I was hardware muted. Yeah, Linux is a special system sometimes. Yeah, so I think I'm just trying to find where I have my screen share. I have like 30 screens open. Okay, maybe I think it's this one. Perfect. Yeah. So that was super cool to see, and I think especially moving to a separate data center, I really like the idea of high availability, and I'll get that into that like a little bit in my section, just because I will be talking about like orchestration and stuff like that. And so definitely super excited to see some of these like big numbers of what we can do and stuff like that. I didn't really plan for like a question and answer period. So if there's questions, I guess we can just save them till the end and see if anybody's wondering about anything. But yeah, thank you so much for that overview. That was really cool, and also to see the history of the OpenStack was pretty nifty. All right, so I'm going to pass it over to Matt now for a brief little overview of some of the student projects that are currently going on. I don't know. Do I need to give you permissions, Matt? Oh, yeah, I don't think I can hear you.
Are you hard muted there, Matthew? Couldn't hear what you're saying. Nothing yet.
Or just while Matt's getting ready here. Andrew, did you have to do anything special to screen share on your end?
Nope, it was the button was there and available. So.
All right, so it looks like Matt can share.
You have the green share screen at the bottom. So, oh.
If Matt can't talk, I can talk.
Oh, okay, Matthew's got the sharing working at least.
Yeah.
How about this?
Hey, perfect. Yeah, that works.
All right. Not 100% sure what's going on there, but apparently my default mic wasn't automatically put on. But yeah, sorry, I can. Sorry about that. My bad. So I have a couple. So yeah, I'll be talking a bit about a couple of the projects I've been working on. I know this isn't everything because there's lots of other students who are working on lots of other projects, but these are the projects I've specifically been helping develop. So my name is Matthew. I'm a fourth year student here at Carleton, and I've been involved with the Carleton Computer Science Society for a few years now. I, along with a bunch of volunteers, have been helping build the projects I'm about to show you today. The first of which is called discretemath.ca, and I just realized I'm not in full screen, so I'll do that now. But the first of which, also, can you see my screen now that I am actually full screen? I know that sometimes that screws up.
Yeah, you're good.
Right, perfect. So the first of which I'll show you today is discretemath.ca. You can actually check it out right now at discretemath.ca. It's a website dedicated to hosting content related to Carleton's computer science discrete math courses. You can find interactive quizzes for the Comp 2804 course on there, ranging back from about 2013 to 2019. We basically have interactive midterms on the website that let you sort of practice automatically sort of taking the midterms. You can submit, automatically get graded, see what you would have gotten if you were to take this test for real. And all this content is just essentially a parsed version of content that was already publicly put out there by the professors who run that course. Some of the things we're currently working on to add to the site in the future are we're looking to add the Comp 1805 content. We're looking to create and add dynamic questions to the website. So currently all of the content on the website is static, but we're hoping, and I have volunteers actively working on this right now, although this feature isn't public, but we have students who are currently working on writing code that essentially allows for the questions to be dynamically generated. So for example, this question at the top here, the you are given 5 books and 7 bookshelves question, how many permutations can you generate, or how many ways can you, order the shelves? I have students basically working through all the different problems on the 2804 midterms and tests to essentially write generators that allow us to not only just generate the question, but also generate the steps and generate a pattern that allows us to see how you would get to the answer with the question dynamically, instead of just having the student repetitively just repeat the generator to memorize how you would do a question like this. So yeah, we've been working on the dynamic questions, and then we're also working on incorporating some flashcard type elements and other content that a few of the recent professors have been working on with Comp 1805. The next project I'll be showing off is a project called Merged. Merged is a sort of student group type news website. The main goal behind this project was essentially to have one platform where students could receive all of the events at Carleton that were happening related to tech. So there's a lot of events that go on at Carleton that aren't necessarily underneath computer science, or maybe there's students who are outside of computer science who want to hear about basically all the tech events going on at Carleton. So for example, let's say you're in CS and there's some event that you want to learn about that was maybe run by the BIT program or by engineering, which aren't necessarily underneath our department. Basically, this website is a news site that features kind of like student-run events and other events run by the university from all of the departments that are sort of related to tech and hopefully would benefit students of that nature. Currently, you can view it on merge.carletoncomputerscience.ca, and if you were to go there right now, there wouldn't be too much going on because it's late December, but normally and at the beginning of September, there was quite a few events on here. We had like a fairly full events page for essentially 3 months of the year before we kind of hit December, where a lot of student groups start to host a lot less events and stuff like that. But we've gotten some really positive feedback on this site, as well as the discrete math site, which I forgot to mention because I've been going through this a bit quickly. But both this site and the discrete math website have received really positive feedback with students. A lot of students with the discrete math website, which again I forgot to mention before, but a lot of people have even cited that it's helped them raise their grades and benefit them in a very positive manner in that course. And a lot of students have given me the feedback on the Merge website that without it they wouldn't have known that a lot of events were even going on, because a lot of the students only receive events that are going on within their department, or a lot of students even ignore their student emails completely because unfortunately some people just don't look at them, but that's kind of on them. The third project I'll quickly go over is this code challenge project we wrote with the Carleton Computer Science Society at the beginning of the year. We kind of ran like a daily code challenge type event. We had roughly like 2,000 unique submissions to the website in the span of a week, which is pretty cool. A bunch of students participated. Essentially, what it let you do is you could view a code problem and submit an answer, and the website would determine whether or not you had actually written code that generated the proper answer, which is pretty cool. We got, I don't know, a good amount of student participation. I think it's just something, it's really hard to run like student events that, I don't know, touch on computer science directly. So it's something, I don't know, that I really enjoyed running. It's something I do again in the future. And again, we ran it on the OpenStack as we have with all 3 of these projects. And those are the sort of 3 projects I came to show with today. Didn't realize this was super formal, but thank you for having me. If anybody has any questions, I'm happy to talk a bit more in depth about those, because I know I went through that very fast. But yeah. Hey, Forrest, I can't hear you, but your mouth is moving.
Thank you, Matt. Yeah, I hardware muted again. I'm just going to take over your screen here.
Okay, cool.
Yeah, so with the projects that Matt is working on, these stemmed from like the Hacking 2804 like initial hackathon, like 1-day thing that we did, and then Matt took the idea of like the discrete math platform and went a lot further with it. But I think that what Matt and I have been working on building over the last mostly Matt, but I've been participating as well, is like building this community of students who want to work on this type of development. And so it's great for side projects. It's great as a way to learn. And it is sort of difficult to maintain over school semesters and over the summer, but it's there's definitely quite a few students who are participating in like building these projects in an open source nature. Okay, so I'm next going to dive in. So Matt talked about like the front end of the projects and how those are looking, how they're helping students, but I want to dive into the back end of it a little bit. And so I recently gave a talk at HashiCorp Deploy called Nomad for Students. And the premise was that I am working on like running or like helping to deploy these applications that like Matt is working on. And I want a way to be able to easily like set these up and get them going and have a way that's also sustainable for students to be able to participate in. And so I don't know what my next slide here is. Okay, it's just a black screen. Nice. I'm going to take just go over to a new tab and show off some of the live side of what's happening here. Just got to pull up my, there we go. Okay, so essentially, the way that a lot of stuff has happened in the past when we've been hosting on the SCS OpenStack is that we would have a single VM that's like running maybe like the CCSS website, or it's running like the election system or something like that. And then we'd have to go to Andrew and talk about, can we get this port forwarded for our website? Then we'd have to go to ITS and make sure that everything is set up there. And that's a lot of work for one service at a time. And so instead, we've been working towards building a sort of cloud infrastructure that can allow us to deploy a lot of things at once through a single egress IP port out of the school computer sciences OpenStack. And so the idea is like we have one IP that's open to the internet, and it can run a whole bunch of different sites on it. And so this works pretty great. It's worked for our different projects that we're running right now. But what I sort of discussed in my talk last week was this idea that we've set up this infrastructure, and it'd be really great if we can start using it for other projects that students are doing as well. And the overhead for adding a new project is quite low. And so if we as like the Carleton Computer Science Society can become a place where people who are running their own projects can come to us, get us to help them with hosting, make sure that they have their services running and hosted, and they don't have to worry about as much, and they can focus on making their project, then we can get a lot more done. And so for this, I've been using a tool called Nomad, and Nomad is similar to Kubernetes in a lot of ways, but Kubernetes is a lot more complex. It tries to solve a ton of problems. It tries to deploy containers. It tries to make sure that all of your ingresses are working. It tries to make sure that you have like the entire stack of infrastructure working. But Nomad focuses instead on single containers. And so with Nomad, I've been able to, if we take a look at like discrete math, for example, I can see that it is currently running. I have currently like the backend, the front end, and Postgres set up. And each of these are running on different containers on one of the OpenStack instances. But we don't have to section it off into its own virtual machine. It's able to run on the same machine that we have, for example, Merged running on right now. And so Merged as well, it has its own Postgres, its own Django instance for the backend, and its own Next.js for the front end. And so if we take a look here at the topology, we're able to see I have 3 different Nomad clients that are running. And so these are just virtual machines that are running in the OpenStack cluster. Wait, did my camera just die? Or is that just, I don't know, whatever. If my camera's dead, that's fine.
Your camera's good.
Okay, cool. Okay, so we have 3 different clients here. Containers can run on any of them, and they can talk with each other just fine. Currently, we're only running it on one client right here. But then the other benefit of this is that we're able to really make solid use of the resources of each of these virtual machines. And so instead of having to have a kernel running on each virtual machine for each service, we have 3 kernels running total. And then the rest of the RAM is just available to all of the containers. And so altogether, we have like a massive almost 200 gigabytes of memory available to us, a ton of CPU power. And this will allow us to scale out several different services that we're looking at running in the future, which I'll get to momentarily. And then sort of how I was talking, where I was talking about was with the single IP ingress that we have from the SCS, we're able to run a ton of different services on it. And so I can say, for example, discrete math API, it should point to one of the specific services, and it will set up the rest for me. And so I really like this sort of approach to running different pieces of software on the OpenStack cluster, because it means that students don't necessarily have to worry about how their products are going to be run. They don't have to go through the bureaucracy of making sure that the ports are set up and everything like that, or making sure that they have their virtual machine configured. And instead, we can have a cloud team that cares about running their infrastructure, or like making sure that infrastructure is running, and then beginning to experience this sort of workflow. Okay, and so we're almost out of time here, so I'm just gonna go over some of like the next future steps that I see us taking in the next few semesters. And so, as I discussed at the beginning, a lot of students are starting to ask, can I get like my M1 MacBook? How am I able to like run local virtual machines, or do I just do stuff in the OpenStack? And we could definitely see that in like this day and age, a lot more is moving towards the cloud. We want students to be able to do a lot more of their work with maybe like GitHub. We want students to be able to use the OpenStack as servers for a lot of their projects. But then another thing that I've definitely found when I was in the first few years of my computer science program is that the VMs that I get given to run on my computer mean that I have to code inside of them, and I get like a really sort of like laggy input, and like there's a lot of potential for me making mistakes on how to set something up maybe. And then that takes up a lot of TA time, that takes up a lot of overhead on how like courses are run, sort of. But then the other side of it is, it is important that students still learn how to use virtual machines, and even what a virtual machine is, because when you think of your computer, it has an operating system. That operating system is a host. You can run virtual machines on that. Those are not very intuitive concepts for first-year students to start thinking of when they're running that virtual machine that runs Python for them. And so last year, I spent some time setting up a Jupyter Lab cluster, or I suppose Jupyter Hub cluster, for Connor Hillen's 1405 course. And I learned a lot about how students make use of an environment like this, for example, with tutorials, and being able to just code in the browser. And so for anybody not familiar, the idea behind Jupyter Hub is that it is essentially a platform that you can go into in your browser, and then it allows you to run Python code, except that Python code's actually running on a kernel on some other server, and then the results are being served back to you. But from the perspective of first-year students, this just means that they can go, when they were doing their tutorials, they can go and log into the Jupyter Hub, have something that runs the Python for them, and then also has it set up in a way that can have the tutorial content right beside the code that will actually be running it. And so this was a really fun thing to sort of set up and help write the tutorials for last year. But one thing I do want to try exploring further in future semesters is taking this idea sort of to the next level, where Jupyter is great because it allows you to run Python on a server somewhere else. But in today's day and age, there's a lot more that's being done on server somewhere else with you having some type of front end to it. And so, for example, we see GitHub Codespaces has come out recently with the ability to have VS Code in your browser that's connected to a GitHub repo, but all of the code is actually running on some kernel in Azure or something. And so this is like the proprietary option that GitHub offers, but then there's also open source alternatives, and the term for this is like Cloud IDE. And so one of the examples that I've wanted to explore, and I've played around with a little bit, is called Eclipse Che. And the idea with this is that you have an interface that allows you to boot up a workspace in whatever language you want. It runs that workspace in a Docker container on some server somewhere, and then exposes a fork of VS Code to you that's like completely open source. And so I've wanted to play around with this quite a lot, just because the idea for students to be able to go in their browser and see a window that looks just like this, and start interacting and coding either in Java or C++ or Python or anything, but then also have an underlying kernel that's doing everything, and they can go to the terminal, and in first year they can start using Linux just through their browser, I think is a really powerful idea. And so I don't think necessarily that this needs to be like a forced adoption by a school of computer science by any means, but what I'd love to see is services that can be run like this, that students can go and give it like a try out, can play around with, can explore, and hopefully it might be able to reduce some of the overhead for either TAs or for courses or anything like that. So this is something that I definitely want to try setting up myself next semester. And I've been playing around with these ideas for quite a while, but I hope that I can finally get around to hosting something like that. So we've explored Jupyter Lab, we've explored hosting something like Eclipse Che, and then I just want to get into another idea that I've been sort of discussing with Professor Hynek here at Carleton, and this is the idea of sort of revamping how the marking server for one of the second year courses works. And so 2402 is the data structures course, and for every assignment you get given a amount of just some questions you have to answer, but then to submit and get marks, you take your code and submit it to a server. That server will then compile it and then tell you how fast your code, or rather if your code is fast enough and if you get full marks. But that the system that this is running on is pretty antiquated, and what happens is that when students when it comes up to the deadline, like 100 students are trying to submit all at once, and it becomes it takes longer and longer for students to submit, and it's running on one server, and that's a lot of work. And so what we want to sort of try and explore is how can we take this idea of just compiling and running Java code, and then sort of set it up on this type of cluster that I've been discussing, where it can scale quite nicely. It has access to all of these resources. It doesn't just run on one server. And then make that into something that 2402 can use. But then we might be able to take it a step further. And so how can we sort of take this idea of not just Java code running, but any type of code running? You can add any types of tests in that you want. And so maybe it's not just for the 2402 course, but instead maybe with comp 3000, you have to get some C code that compiles and then runs on a container and has to interact with the kernel in some way or something like that. And so I think that this would be a really cool way to have a lot more of the course's assignments be sort of interactive in this way, where students can find out their marking ahead of time, and then have infrastructure built around this. And so this is an idea that I've been discussing with Dr. Hynek, and we've sort of explored what would this look like if we were to try and open it up for more people to work on. And so in the past, there's been some TAs who've sort of worked on a system similar to this. But what I'm really interested in is making sort of an open source, or rather openly developed version that can do a lot of this. And so we already have access to the infrastructure. The School of Computer Science is super kind at making sure that we all have the ability to use the resources that we need. We have students who would be interested in contributing to this. We have the need for courses or need from courses that want to use a platform like this. And so I'm hoping that this is something that I can sort of take to the next level over the next few semesters. All right, so that is it for the few different talks and overview and kind of what's going on with a lot of the systems right now. Let me see here. So essentially we have a lot of really cool and exciting stuff that is going on in the School of Computer Science OpenStack. I really like the sort of the vision of where the hardware is moving to and stuff like that. I really like the opportunity that I have to work on a lot of these systems and see students who are able to contribute and work on their own projects that can be hosted. And so if you want to sort of be a part of some of this, we recently started a School Computer Science OpenStack Teams project, and the idea is for it to be relevant to people who are making use of the OpenStack, to either ask support questions or be able to talk with other people. And this is it's not like a super general purpose, or as of right now, it's not a super general purpose question and answer place for everybody. But if there are people affiliated with Carleton, either students or researchers or professors or anything in between, feel free to reach out and we can see if we can get you on there. I'd love to have more discussions on there about more asynchronous or synchronous or asynchronous discussions about the cool stuff that is going on. And then also, if you are interested in getting involved with the students side of you, we have a lot of the projects that we're working on from the Carleton Computer Science side of things. All of them are open source. All of them have a lot of areas for potential contribution. And then also on the side of cloud orchestration, I've been working with a few other students to kind of play around with a lot of these ideas of hosting stuff on the School of Computer Science infrastructure, and then using a lot more of these cloud native sort of applications to do a lot of this work. And so I hope to find more people that, or more students that are interested in doing some cloud stuff. And so again, feel free to reach out to me if you want to participate in some of this. And so I didn't make a final slide. Let me just add that in quickly. Thank you. Okay, here now if I reload this. So thank you everybody for coming out to the first OpenStack sort of meeting, kind of just talk about what kind of cool stuff we got going on. I really like seeing a lot of the work that's going on like behind the scenes and everything like that. And so I hope that maybe this might inspire some other people to try some cool stuff as well. So until we have a second meeting, I suppose I'll see you next time.
Yay, thanks, Forrest.
Yay. Well, I don't know how to stop recording. Do I want to stop the cloud recording?
Thanks.
I click no.